Let's solve an application problem that involves rational equations. So the problem says you drive to your family member's house a distance of 40 miles and return on the same path. Your average rate on the return trip is 30 miles per hour faster than the average rate on the outgoing trip. If the round trip takes 2 hours, what is your average rate on the outgoing trip? So let's go over the steps on how we would actually solve this problem. So the first step is to let x represent the unknown quantities. The things that we do know is that our total distance each way is 40 miles. Okay. The other thing we know is that one trip was 30 miles an hour faster than the other trip. And the last thing we know is that the total time was 2 hours. So those are the things that really are going to help us. What we are trying to find is the average rate on the outgoing trip. So what I'm going to do is we're going to let the outgoing trip its rate equal x. The second step is to find other unknowns in terms of x. Let's think about that 30 miles an hour faster. The return then, if my outgoing is x, then my return would be x plus 30 because we are 30 miles an hour faster. Now we can think about how all of the information that we have relates together. We have a rate, we have a distance, and we have the total time, outgoing and for the return trip, is 2 hours. So step 3 is to write an equation that describes the conditions. So, like I said, we know that we have a rate, a distance, and a time. An equation that we have that relates rate, distance, and time is distance equals rate times time. Well, we know the total time is 2 hours. So we want to find an expression first that relates the two things we know, which is distance and our rate, to that 2 hours. So we will use the equation time equals distance over rate. So we have two different times, the time for the outgoing and the time for the return. So the outgoing time is 40 miles divided by x. That's how long it would take to drive to the family member's house. The return trip is 40 divided by x plus 30. And those two times together, the 40 over x plus the 40 over x plus 3 is equal to 2 hours. This is the time outgoing, the time returning, and there we have our final equation. All right, I made one little mistake. I forgot to add the 30. I just put 3, not 30 on there. So step 4 then will be to go ahead and solve the equation and then answer the question. So we need to multiply through by the least common denominator. So we have the x cancels out there. We have 40 times x plus 30 plus the x plus 30 cancels out, and we have 40 times x equals 2 times x plus 30. Now we just have some distributing to do. 40x plus 1200 plus 40x equals 2x squared plus 60. Sorry, 60x. All right. Now, let's bring everything over to the right side of the equation here, we end up with 2x squared. Then we have 80x, subtract, or 60 minus 80x is minus 20x, and then minus 1200. From here, we just solve this quadratic equation by factoring a 2 out. And then factoring the equation. So we have x, let's see, 600 would be, 6 is 3 times 2, so 600 is 30 times 20. That is a difference of 10. So we've got minus 30 and x plus 20. So that means that x can either equal 30 or negative 20. Now we have to answer the question, and that's a very crucial part to step 4. So what it says is, answering the question is, what is the rate of the outgoing trip? Negative 20 cannot be the answer because you cannot have a negative rate. So that means that our outgoing rate must be 30 miles per hour. And then last, just maybe check to make sure your solution makes sense. And 30 miles per hour, that should work. It's, let's see, 40 over 30, that's like 1 1/3 hour. And then 40 over 60 is 2/3 an hour. So 1 1/3 hour plus 2/3 an hour is 2 hours. So those 2 hours, or the two rates, match up. So that means that our outgoing rate should be 30 miles per hour.